Alright, so to complete example number 3 from class, particularly for Mod 1, water runs into a conical tank at the rate of 9 cubic feet per minute. The tank stands point down and has a height of 10 feet and a base radius of 5 feet. How fast is the water level rising when the water is 6 feet deep? So we've drawn the picture, we've written down the particular information. We're looking to derive the volume function. The volume was 1/3 pi r squared times the height of the tank. Now we talked about looking at the volume function. It's in terms of R and H. So if we wanted to derive the function, we would need the product rule, and we would need the rates of change of the height of the water, which we're looking for, and the radius of the water, which we don't have. So given the dimensions of the tank, 10 feet high, with a base radius of 5 feet, we looked at similar triangles. So we're looking at the exact instant when the height of the water is 6 feet. So if we take similar triangles, so the height of the water at any given time to the radius of the water is proportional to the height of the tank and the radius of the tank. So again, the ultimate goal is to eliminate R from our volume function because we don't have any information about the radius. So solving this equation for R, we get H over 2 is equal to the radius. So now what we're going to do in our volume function, we're going to replace radius to be in terms of the height. And I believe we got this far, but just as a reminder of where our notes came from. So now we have pi over 12 times h cubed. Now this is our function for the volume of the tank, strictly in terms of the height of the water, which is all the information that we have. So now we're going to derive this function with respect to t. So dv dt is equal to pi over 12, that's a coefficient, times 3h squared using the power rule, and then dh dt because we're deriving with respect to time. We're looking for dh dt, so now we plug in all the information that we have. We were told the rate of change of the volume was 9. And what we can do, 3 over 12 reduces to 1/4. So again, without the aid of a calculator, try and reduce and make it any easier for you. We were looking at the tank at the exact moment when the height of the water was 6 feet. So we replaced the height with 6. Pi over 4 times 36 times dh dt. 36 divided by 4 reduces to 9 pi. And then solving for dh dt, divide both sides of the equation by 9 pi. Just be careful to leave pi in the denominator. So the rate of change of the height of the water in the tank is 1 over pi, and then our units, feet per minute. So there's at least one homework problem that deals with having to use a similar triangle relationship to attempt to replace one variable in the function in terms of another.